So as I was saying then, at the end of Eg1, we had a general solution to that equation because we weren't given any conditions to allow us to establish what the constant was. If we are given those initial conditions, then rather than finding a general solution, we find a particular solution. So where a question's asking for a particular solution, first of all you get the general solution with the constant in, and then you evaluate what that constant is. So Eg2, find the particular solution of the differential equation dy dx equals y squared sine x. Okay, I'm solving a differential equation. The only way I know how is to separate the variables. So the variables are going to separate here to be 1 over y squared dy by breaking that multiply and bringing it over, and then bringing the dx up. Now, one of the big challenges with integration is there are so many different things you need to be looking for or trying to spot. With this, it's a 1 over, so you're tempted to go ln, but ln, natural log, is only for the specific situation where it isn't to a power underneath. This one is more basic. You're going to write it in index form first of all. So bring the y squared up and it becomes to the power of -2. And what I like to do with my integration is do any manipulation first. So even though I could have integrated that side at that point, I do all my manipulating, and then when I'm able to integrate both sides, then perform the integration. So integrating this, I add 1 to the power, which is going to give me -1, and divide by that result. So I'm going to have 1 over -1, y to the -1 equals, and then when I integrate sine, I get minus cos plus c. So this gives me 1 over -y equals minus cos x plus c. And because I'm trying to work out what that constant is here, then I can do that now. So I know that when y equals 1, x equals 0, so 1 over -1 equals minus cos of 0 plus c. -1 equals cos of 0 is 1, so that's going to be -1 plus c, so c equals 0. So therefore -1 over y equals minus cos x, and what I want to do is to have the y not as a denominator, so different steps to go here, up to you which way you go. I don't want to lose you, so how about if I go -1 equals minus y cos x, -1 over minus cos x equals y, y equals 1 over cos x, minus divided by minus is a plus, and 1 over cos is sec. So the particular solution for that differential equation at that set of initial conditions is y equals sec x. How you get from there to there, there's different ways to do it, and certainly you could do that in many fewer steps than I've taken there. I just thought that that was the way that would be easiest to follow.